Okay, in previous video we have discussed about how the data structure is implemented from ADT, and we have tried to write down a pseudo program using some programming language like this is something related to Java, and we try to write the program and we try to enhance that as well. If you look at, we put some code around here and we try to bring more refinement into this program. Okay, so after writing the code and you execute the code, and the output should be as coming to in the next slide. It is like the blue should be like A B A C A D, B B A D C and D E D. Let us check that. So these should all be uh, uh, blue color, and those are like you can say. Okay, you can mention here is this. Okay, A B A C A D B A D C E D. Okay, A B A C A D. Then comes what? B A D C A D. Okay, then B A. So A B is going like this. B A is going this. D C is going this way. Okay, A D is going this way, and D C is like this, and E D. E D also can be. Then comes red, for example, ED, E and D. So AD is going on, ED will go through this. Okay, so there is nothing to stop. It is not coming this way, it is coming this way. Okay, right side here it is coming this way and going this way. So right side driving, remember that this whole thing is right side driving in US. So this is how it is coming out. And similarly for red, and whatever BCBDEA, let us check that BCBD and EA. BC, when it is going BC, BD can go and EA can go. So those are the turns we can take. And what are those extra turns we can discuss about is like there is no extra turn here in the first one, definitely, because everything is connected to one of these, so we cannot take any turn over here. Whereas there are turns like when you take BC, can we take BA? Okay, let us check. When you take BC, can we take BA? Can I take BA? Yes, I can take, because BC goes this way and BA goes this way. There is no connection, and that is an extra turn. Basically, there is no stop. There is no need to stop that traffic. Like DC and ED is going on. So DC and ED. Let us check. DC and ED. So this one BC is going on, DC is going on, and ED is going on. So definitely we don't have any problem. But here BC is going on, so we are not allowing EC. Okay, if you look at, we are not allowing EC. Okay, we are not allowing EC here. But extra turns, because there is no connection to this, is BA, DC, and ED. So that those are the extra turns: BA, DC, and ED. So BA and DC and ED. So they don't have any, um, uh, they don't have anyway, they are not hindered by this kind of a other the traffic that is going on, that is BC, BD, and ED. With that, DC can go, BA can go, EA can go, because they don't have any kind of a connection, or any kind of a traffic violation is happening, or collision can will not happen. There is no need to stop them. So during this, you can allow these people to also move around. Similarly, we have those extra turns. So the extra turns, we have to find out that what are those extra turns we can do. So once we write the program correctly, then we need to find out what are those extra turns. So this is something we have to write in a particular, in that program itself. You write that what are those extra turns we can take. Okay, like BA is independent, ED is independent. So these are independent ones, so they can move at any point of time. With the NDC is independent, so those turns are allowed at most of the time because those are all independent. If you look at here, BADCED, 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 these three are always allowed. Only thing you have to look at the other two extra turns AD and EA during this these two, whether we should be allowing these two turns extra turns or not. So those extra turns also you have to look at. So those extra turns should be given during this during giving the red. They may not be colored as red because they cannot be colored as red. They already colored here as blue. So we need to see what are those other colors which are independent of the turns that we are giving here. So those are the colors which we can give as an extra turn. And that is what the traffic problem. This is the output you should be getting. This is the output you should be getting, and this is something you have to work it through. Then we can, and then we will have the final answer to the traffic problem. Now I have put another question for your exercise. You can try it out. It is exactly the same. If you look at, there are six teams in IPL league cricket team, IPL league cricket. The RCB, MI, KKR, RR, and CSK and Sunriser. The RCB has already played these MI and KKR. MI is already played with CSK and Sunriser, and CSK is already played with MI and Sunrisers. Okay, because MI is here, it is mentioned. MI has already played with CSK, so CSK is played with MI. But MI CSK is also played with Sunriser. That also we have to mention. So those are the games already played. Now each team plays one game per week. That is the condition. Under this, find a schedule so that all teams will have played each other in the fewest number of weeks. Okay, that is something we have to look around, that how we can create a schedule so that each team will play the other team in a fewest number of weeks. But remember, each team will play one game per week. They cannot play more than one. So that's how it is. Okay. Then comes here. So you can create a graph. Hint is given. You will create a graph with the vertices where the teams had not played. Okay. Pair of teams though that have not played. That is the vertex. Okay. The vertex you should be remember. Then you try to find out what should be the edge. Edge will be so that the legal coloring of the graph. Each color can represent the game played in 1 week. Okay. Each color can represent games played in 1 week. Okay, what should be the adjust B so that the legal coloring of the graph, each color can represent games played in 1 week. So we can take that each coloring of the graph is like that, is like that, that each color represent game for 1 week. So in that particular week, how many will be playing each other? Okay, so that week, then next week it will go. So week wise, so edge will be, you can take it as a week. Okay, this week one gone, then it is next week. So why week one, week two, you have to put like that, and you have to create the graph. Once you create the graph, then you can write the normal algorithm, and we'll try seeing that how the output is coming. So you can try at your own end and see if you are able to resolve that. Otherwise you can connect me. I'll help you out. Thank you.